In this lesson, I'll talk to you about the .NET Stack versus the heap and how memory management differs between the two. In order to write efficient applications, you have to understand a little bit about memory management and how it's allocated. This is particularly true in the .NET Framework. This is mainly true in the .NET Framework because the way memory is managed on the stack is different than the way memory is managed on the heap. Variables on the stack are referred to as what are called value types, and variables on the heap are referred to as reference types. What exactly does that mean? Well, let's take a look. Value types mean that the memory is managed on the stack and on the stack only, and they directly contain their own values. The heap isn't used in this process at all. So let's look at this declaration. We're going to say int I, so I'm declaring a variable I, which is of type integer, and I'm going to assign it the value 5, and notice that I directly contains the value 5. When I then declare j as another integer, notice that j is allocated, and then I'm going to say j is equal to I. In other words, I'm going to take a copy of what's on the stack and assign it to j. If I now make a change to I or j, it doesn't affect the other because they both have their own copy of the data. Here I've got a little function called run stack demo. Let's take a look at what the function does. Basically does exactly what we just looked at before. I'm going to create integer I, and it's going to allocate memory on the stack. Then I will set it equal to 5. Then declare variable j and set I and j equal to each other. Here I'm going to actually increment j by 1, and you'll see that when we output this information, we'll see that I is unaffected by the change to j. Let's go ahead and set a breakpoint right here. And we'll see that I is allocated, and since it's a variable type, it defaults to 0. You can see down in my autos window that I has assigned the value 5. J just took the value of I and is also set to 5. Now we're going to increment j, and we can see that j incremented to 6, but I was unaffected. So now when I go ahead and print this out to the console, we can see that the value of I is 5 and the value of j is 6, just as expected. So how does this differ with reference types? Reference types are different because they don't directly contain their own value, and as you'll see, the heap is used in reference types. First, I'm going to declare an array list called list1. Before I can assign a value to list1, I have to create memory on the heap. So we can see that the keyword new array list allocates memory on the heap, and then the equal operator will take the memory reference of that new array list or that new memory on the heap and assign it to list1. So list1 doesn't directly on the stack contain a list at all. Instead, it contains a reference to memory on the heap. I'm going to add a value to the list. List1 add 5, and then I'm going to declare a second variable called list2, and we'll set list1, or we'll set list2 equal to list1. Now, just as before, we're going to take a value, or we're going to take a copy of the value of what's on the stack, copy it, and give it to list2. In this case, that copy is just a reference pointer to the memory on the heap, and it happens to be the same memory. So in list1 we've added another 6, and notice on the heap it's added that value, but it's actually also affected list2 because they're both pointing to the same memory on the heap. Let's take a look at that in a demo. Okay, so here we are back in our code, and notice we've changed. Now we're going to run the heap demo. Here we've got our array list, list1, allocating the memory on the stack. With the new array list, we go ahead and create a new memory allocation on the heap, and we assign a reference to that memory location to the variable list1. We'll go ahead and add one number, 5, and then we'll create another array list called list2 and set the value of list2 to whatever the value is of list1. Remember here at this point we're copying what's on the stack, a reference to the heap, and assigning it to list2. So both list2 and list1 point to the same memory reference on the heap. Now when I say list2.add6, I'm adding another number to list2. We're going to loop through both lists, and we'll see that both list1 and list2 will have the number 5 and the number 6. Let's add a breakpoint. So we create our memory reference, we add a new item to list1. Notice that list1 has a count of one item in it. List2 has just been declared, and list2 has a null reference because it isn't pointing to anything at the moment. But we just assigned it, so list1 and list2 both have a count of 1. Now notice I'm going to add the number 6 to list2. List1 and list2 both have 2 items. Even though I only incremented list2, you'll see that list1 also incremented to 2. Now let's go ahead and run through the rest of this, and we'll see the output. List1 has a value of 5 and 6, and list2 has a value of 5 and 6. Variables that are managed on the heap, or objects that are managed on the heap, are not directly accessible by our own code. They have to be accessed through the variables that are declared on the stack. So we can see here, if we've got a function, public void do work, we declare variable array list list1. It points to our heap just as we noted before. However, as soon as we go out of this code block, out of this function block, list1 goes away, and so there's nothing managed on the stack anymore. However, variables on the heap still persist. So as it's there on the heap, we think, well, we've got a memory leak. This is what garbage collection is for. I discuss how the garbage collector works in another lesson. In this lesson we talked about the difference between variables that are managed on the stack, or memory that's managed on the stack and on the heap, and specifically how it relates to the types of variables that we declare. More specifically, we have variable types that are called value